Hello students, today we are going to discuss about the statistics paper of ISS 2021 which happened in the 16, 17, 18 July 2021. Okay, so in this video, so let's talk about the entire question and we'll discuss on the answer patterns and everything. There are total 14 questions as you can see, divided under the 7 sections. Candidate has to choose any 2 sections and attempt the questions from that. This is you already know, so this you can choose according to the different areas, but I will be explaining all the possible choice options. So this is the first one, section A. This is one of the most likelihood. Here the name is operations research and reliability. Mostly it is considered with the LPP problems and problems on analytical framework and definition and scope of operation research is there. There is assignment problem and all these things are there. So this is relatively a scoring. The first one is actually a sequencing problem, and here you need to do it by the 3 machines. So first, step 1 for this machine is you just add 3 plus 4, 8 plus 3 in that way, and in the next step you add these 2. So in that way the interconnection is being done, and then you put it into this 7 jobs format, 1 2 3 4 5 6 7, and you go for the sequencing. And total elapsed time required to complete the following task is also can be calculated. Even also time gap or idle time can also be calculated. So this is a 10 mark question. This is relatively easier one to start. I should obviously recommend you to go for this. The second one is a payoff table, transfer of a zero sum game into a equivalent linear programming problem and solve the game into simplex. So very easy structure. So in just simplex, so this 3 into 3, remember that simplex can also be solved into a 2 into 2 structure or even a higher pattern as well. So in a 3-dimensional structure, why we can't apply without simplex here, because in the graphical method it's always a 2-dimensional structure. Okay, so we get this graph, we solve the solution points and we solve it. But here in the simplex structure we can do it. This one is a relatively fairly easy one, and the payoff and a zero sum game is profit of one equal to loss of another. So at the end of the day there is no extra profit or extra loss. Okay, so this is very simple and important. Next is a supermarket has 2 girls ringing up sales at the counter. The service time for each counter. So this one is about Poisson distribution. Okay, and rate of 10. So here you can apply the Poisson distribution, e to the power minus lambda to the power x by x factorial formula, and expected idle time into putting this structure is also associated with 1A's pattern, so not so tough. Customer and average waiting time, expected waiting, for this one you need the actual formula. So this is a relatively easy first 3 questions. Okay, so let me just get back to the upper part. Yeah, so after this the next question is, it's a manufacturing company based structure, and you assign more economical purchasing policy for the company. What advice would you offer if you would need to save the company per year? So it's a cost benefit analysis would be done. For this I will do a specialized video on this. The full solution will be provided. Okay, so ordinary requirement based structure, and this is also we can do it by anti structural analysis, and we can solve it directly. Okay, let's go to the next one. Describe the project evaluation and review technique, PERT CPM type question, and it's procedure stepwise. A small project is being taken, so IJ. So here also estimated durations are being optimistic, most likely, and pessimistic. So here project networking drawing. So this one you need to work on only one thing, that the best suitable way. But the main problem of working with this one is a little bit longer, but obviously choosing is very important because this has some subsectional analysis as well. Okay, and in the next part answers any 2 questions. So this first one is an assignment, this one is an assignment problem. So in the assignment you can do it with respect to take the 2 minimum from the every 2 row and subtract that every minimum from every row and subtract the values. So here you can do it, the 28 is the minimum, so the first row will be like 4, 10, 12, 0 and 12. In that way 21 will be here, so 0, 19, 3, 7 and 9 sorry 7 no sorry 21, so 15. And then 27, and in the similar way we can go it for 22. In the similar way we can go it for 29 as well. And after that the same will be repeated with respect to the columns as well. And then we try to add up with respect to the minimum zeros with each row and each column as 1. So this one is a fairly very transparent and very direct question. So this one you can get around obviously 10 out of 10 if you do it, but don't forget to write the assignment cost, total assignment value. Okay, and next is describe the algorithm for solving n jobs in 2 machines. Optimal sequencing, another problem. Okay, and total elapsed time, also find the idle time for machine A. This is quite unusual, they give it the same type of question into 2. Okay, so here if you need my help, so I will obviously solve it. Some of you have requested me for especially this sum, so 1 2 3 4 5, 1 2 3 4 5. So with respect to the all, what is the minimum is 3. Okay, 3 in the machine A, so you start the first job, so this is your job 1. Okay, machine A from this side, machine B from this side. After 3, so obviously 4 we cannot consider, so 3 is been taken already. So after 4 there is a 5, there is a 5. Okay, so this 5 will come here, so this is 3, and this 5 will come here, so this is 4. Okay, after 5 all these things are done, so 6, so this is also from this side, so this is 5 and only one left, and this is 2. So this is the sequence 1 3 5 2 4, and after that when you just enter into this structure, now you need to solve it for idle time. So how to do it? So for machine A, so let me just do it for machine A. Let me just clear it. Yeah, for in time out time, if we just do machine A, in is 0. First is you will be doing job this, so 3 hours, then 3, then he does job 3, so this is 8. Then he enters at 8, job 5, so that is 6. 14, then enters at 14, just job 2, so 22. Then enters at 22, just job 4, so that is 29. This is for machine A. No idle time for machine A. And for machine B, he enters the job 3, and this is the idle time, first 3 hours, and he takes it again the same pattern. So this terminal 1 3 7. It can't enter at 7, it will enter at 8, so 1 hour idle time. So this time it will take 3 hours, so 6, so 8 plus 6 14. And after 14, this time it will enter 14, no idle time, and this time they will perform 5, so 22. So this time also 22, no idle time, and it enters at 22, finishes up with job number 2, which is job number 2, so which is still 32, and it enters at 32. And this time the total timing will be 32, and last job is 4, so 37. So 3 hour idle time, and here it's finishing, so 3 3 6, 7 hour is the total idle time. So see, in the first case where idle time was not need to be calculated, only this series, so 10 marks, and this is for 15 marks. Okay, quite a lot. Sometimes they give an extra marks for this. In graduation we used to get only 4 or 5 marks for this stuff. So anyway, that's why 200 marks and 3 hours, and normally it is 100 marks 3 hours for our graduation days. So now is a BFS, basic feasible solution of the transportation by Vam-Vogels approximation method. And here the good old process. So you need to find the two most minimum, 2 and 3, 1 4 2 and 3 again 1, 1 and 3 again 2, 2 3 1 2 3 1 2 3 1 1 2 1, and 2 and 3 again 1, possibly next one will also be 1. So among them the maximum, so this will be the zone where it will be working. Now you compare with the, so this is the row to start off, sorry, this is the column to start off with the maximum distances. So this is pretty much standard VAM based problem, and using Modi method also find the optimization of the problem. So that's why 25 marks have been given. So the approximation is 10 plus 15 is the thing we can take it. So obviously this one is a pretty direct one. And next is a commodity is to be supplied at constant rate of 200 units per day. Supplies of an amount can be had at any required time, but each order costs 50. Cost of the holding of the company of the inventory is 2 per unit day, while the delay of the supply. So find the optimal policy calculation based problem. So here what would be the policy? The penalty cost is infinite. So direct structure, direct application method, here you can apply in order to solve it. Next is MMN FE4. The next one is a queuing problem, and they can find the probability of excluding the service time of the distribution. So it is quite direct as well, so you can do it by the normal theory as well. Okay. Next is a record lifetime for an identical items as follows. Assuming that lifetime has a gamma distribution with parameters this, find the estimated failure rate. Okay, so gamma distribution, directly you can apply this thing. Okay, one thing I should give it to you. So the gamma distributions actually having a double parameter structure. Okay, the PDF of the gamma I am writing so that it will be helpful. This is the gamma function, gamma k, theta to the power k, and x to the power k minus 1, a to the power minus x by theta. Okay, so these are the deciders, and all are 0 to infinity. Okay, in another way we can write beta to the power alpha or gamma alpha as well, into x to the power alpha minus 1 into e to the power minus beta x. So these are the two normal common forms of this structure. And remember that here k is the shape parameter, and theta is the scale parameter. With the shape parameter alpha equal to k, and inverse of the scale parameter is beta equal to 1 by theta. So this is called also the rate parameter. Okay, so in this way very easily, pretty directly you can put these values over here. How many values? 1 2 3 4 5 6 7 8 9 10, so 12 cases, so that you can do. Next, consider the item with the failure. Obtain the reliability function, conditional survival function, and mean time failure and mean residual time. Okay. So mean time between two failures also we can here we can start off your calculations. Okay, so it's like one failure, and then this time, and then the second failure, then you do an inspection after the first failure. This is also a possible type of working as well. Okay, and there is a formula for this directly. So the calculation of MT first MTBF 0 to infinity r of t dt equal to 0 to infinity t f of t dt. So this is the density function which we are talking about, or of the time until failure. So this is the time until failure. So ft equal to lambda e to the power minus lambda t. So this is the functional structure it follows, and the failure rate is MTBF is 1 by lambda. Okay, so this is the adaptation of structure which we can apply here. by this we can do it. Okay, this is the actually tougher part, but the rest of the thing is also conditional. CSF also direct formula is there. So this time mostly the problems are can be done by formula based analysis. And with respect to CSF here, so this is actually to investigate the survival distribution of the uh, structure directly, and basic analytical framework can also be applied here. Okay, so in the next part, the demography and vital statistics, this will I will do it in the video number 2 for this paper 4. Okay, thank you.